You have looked into a guy in China who's reported to have lived for 250 years.
His name was Li Qingyuan. Born in 1678, he passed in 1933. You believe it or you don't?
I can't say with 100% certainty, and no one can.
Well, go back your grandfather 10 generations ago and tell me if you can find their birth certificate. At 250 years, he's offered a chair. He refuses the chair. He's sitting down on the floor with his back straight. He was using a lot of plants. Trust nature more.
Really?
You're listening to The Human Upgrade with Dave Asprey.
Today's episode is all about the innate repair system in your body. Because if you want to live for a very long time, or you just want to recover faster from whatever you did last weekend, you can change how your body recovers. It'll either recover quickly or it'll recover slowly. And there are different repair systems in the body. So our episode today comes with a powerful expert who happens to be a black belt in Taekwondo, amongst many other things. His name is Christian Drapeau. He's been on the show before. He's a friend, founder and chief science officer of STEMREGEN. 20 years of studying stem cells and has a degree in neurophysiology and has scoured the planet looking for plant compounds that will activate stem cells. The reason I'm so interested in this is that I do $50,000 stem cell procedures, and most people aren't going to do that, at least now. And I recognize that. So what can you do that activates and moves your stem cells around to the right places that doesn't break the bank? And Christian, in those 20 years, figured out some ways to do that. And it's stuff that I use. It's stuff that I send to my parents. So I found he knows a lot of core science. I was exceptionally skeptical when I first met Christian and he talked about what he did. I'm like, yeah, right. 10 million stem cells from taking a couple of capsules. I don't believe it. And we went really, really deep on the science, and he showed me what he was doing and how it worked. I'm like, wow, this is one of those things that radically lowers costs. So today we'll probably talk about some of those plant things, but that's not the point of it. The point of this today is for you to understand how your innate repair system works and the different things you can do to turn on healing and to turn on longevity. And I think you're going to find he knows things that you won't typically hear anywhere else. Christian, welcome to the show.
My pleasure, Dave. Thank you.
How does the innate repair system work?
Just like you have an immune system, nobody puts that in question. Everybody knows that you have an immune system. In the exact same way, you have a repair system. So you get an injury. Let's make the comparison with the immune system. You cut yourself. You have a bacteria that gets into that cut. It will trigger the release of immune cells from your lymph nodes. These immune cells will be attracted specifically to where you have a cut. They will go there. They will migrate beside the bacteria. They will kill the bacteria. This is very well coordinated immune system. Your stem cells are exactly the same. You get an injury, it releases compounds that will go to the bone marrow, trigger the release of stem cells from the bone marrow. We can quantify an increase of up to 10-fold in the number of stem cells after a significant injury. Then the affected area will release other compounds that will attract stem cells to that area. Stem cells will migrate into that tissue, and upon contact with cellular debris of that tissue, stem cells will become cells of that tissue. So it's your repair system. And what I find fascinating in this is that every single human being on the planet, without one exception, have experienced that the body repairs. Everybody has had a cut, a broken bone, a bruise, whatever. Everybody observes that is witness to the fact that their body repairs. And yet in medicine, until stem cell research discovers the natural role of stem cells in the body, we did not have an understanding. Nobody brought up the question, how does the body actually repair? You get a broken bone, the doctor puts you in a cast, says, come back in 6 weeks. We take off the cast. There's no language about what do you do during those 6 weeks to help your body repair. It's because we did not have an understanding. So that's the repair system.
We know that as you age, your immune system becomes less effective. And one of the things that's likely causing a substantial amount of aging is inappropriate activation of immune response. Inflammation. So this could be food allergies, environmental allergies, or even autoimmunity. And that this tends to make you old and lower performing in the meantime. What's the difference between activation or inappropriate activation of the immune system versus the innate repair system from stem cells?
In terms of stem cells, the best answer that I can give you is that I'm not aware of an actual like activation of stem cells that could be excess activation of stem cells. We have two things that work together. One is the aging of stem cells. Like they age just like any cells, actually more than other cells because they divide so much in the body. So you get improperly folded proteins and everything that comes from a very active cell accumulates in the cell. So autophagy. And actually, it's interesting to see that fasting that triggers autophagy. Some studies, not enough has been done, but from what has been done, if you take a stem cell from the bone marrow and then you have the person and you test its ability to proliferate and migrate into a tissue, and then you get that person do a 3-day fast, then you take another sample of their bone marrow, the stem cells have rejuvenated during those 3 days. So post-fasting, they will migrate more easily, more effectively, will multiply more effectively. So there's some evidence to show that your stem cell age, but you can rejuvenate them through a fast. That's the first thing that happens to sort of modulate or modify the ability of your innate repair system to function in the body. The other one is simply the fact that red marrow converts to fatty marrow as we age. That happens very early in our lives. By age 15, we've lost 50% of our overall red marrow. In our 30s, it reaches 90%. So as a young adult in your 30s, you start to realize one day you don't repair as well. That's just because you don't have as many stem cells in circulation. That is probably like the main difference that happens as we age. It's a decline in the number of stem cells available to participate to tissue repair.
What can you do to have younger stem cells besides fasting?
I would say the only thing, and it's not a great response, is that you have stem cells in your body that do not multiply a lot. So they then remain younger. So these are fat adipose stem cells. There's a new type of stem cells they're called Muse stem cells, multi-lineage. You've had them? Mm-hmm. Great. So these are stem cells that tend to remain extremely resistant to changes, stress. So they tend to remain young. So they're young stem cells. If you try to rejuvenate your own stem cells, I mean, at this point, fasting is the only thing that I know. Do you know anything else?
It looks like senolytics can do the same thing.
Senolytics, I'm not aware of the role of, I don't know if the role of senolytics have been studied in stem cells. In other cells, they will tend to basically, apoptosis is the sort of the right end path of senolytics. You make them disappear and you replace them. And they're replaced by stem cells.
They are replaced by stem cells. In one of the protocols I've used, you use pharmaceutical senolytics for a little while before drying marrow cells so that you get rid of all of the older, weaker cells and you get a younger cohort. Doesn't mean you've reversed the age of the stem cells, but you get ones that are as young and healthy as they can be. And so I've got 2 billion marrow cells banked, and I've had my fat stem cells banked for 8 or 10 years now. And for listeners, if you get a chance to bank your stem cells, it's a really good idea. However, these are expensive procedures to do. And I think it's worth it if you have lots of money. And if you don't have lots of money, the easiest thing to do is say, well, how do I make my body release stem cells like I'm young? And you can do that with STEMREGEN. Very briefly, tell me how STEMREGEN actually makes the body release more stem cells.
STEMREGEN is made of plant extracts that have all been documented by quantifying the number of stem cells in the bloodstream using flow cytometry to put more stem cells in circulation within just a few hours of consumption. And by the way, it's the normal physiology of stem cells. They don't stay in your blood very long. They're released, they go into tissues, or they go back to the bone marrow. So the fact that we find that the effect is short-lived, it's almost like an indirect confirmation that what we're documenting is real physiology of stem cells. The way that it's doing it, the simplest way for me to explain it is just like when you have fasting mimicking compounds, let's call them injury mimicking compounds. They trigger in your body the same kind of reaction that would happen if you have an injury and suddenly that injury is calling for stem cells. So it's the release. We can pick up in the blood certain compounds like GCSF, GM-CSF, stem cell factor, SDF1. These are all compounds that modulate stem cell function in the body, and these plants just happen to modulate the secretion of these compounds in your bloodstream. So in a nutshell, that's what we do.
Okay. Makes sense to me. You're causing the stem cells to get released more. Are you going to somehow negatively affect your body if you're causing it to reduce or to release more stem cells than it normally would? Are you going to run out?
I mean, I can answer this question from different angles. Number one, which is to me like the most obvious, how did we find those plants? We found these plants by looking at plants that have been used historically, like for centuries, and have been historically associated with many different kinds of benefits. Because if you release stem cells, they will go to the pancreas of the diabetic, the heart of the heart patient, the lung of the person with emphysema. So you would expect a broad variety of benefits. I'm looking for those plants. And these are the ones that we have now in STEMREGEN. So you look back, and these have been used for centuries. So if these plants or releasing stem cells has any impact, negative impact on the body, it would have been picked up in history. So that's the first way to say they're safe. They've been used for a long time. They're safe. A second way to answer the question, athletes, like Olympic athletes, like intense athletes, the people who will train every day for, let's say, a decade or more. Every time you have a very intense physical activity, you release a lot of stem cells. So are athletes running out of stem cells? No, they don't. And the last angle to answer that question, there's a study done. I won't go into the detail of it because it gets complex, but the answer is mind-blowing. The question was, if we do myoablation, like what you do in a cancer treatment, leukemia treatment, you kill all the bone marrow, how many stem cells do you need to inject to make sure that you can rebuild the bone marrow? And the question was, if you have only one stem cell, but you know it's a stem cell, is that enough? And the study have shown that if you inject one stem cell, you can completely, in 6 weeks, reconstitute the entire bone marrow in the blood system.
Wow.
So releasing 10 million out of your old bone marrow bank is like you taking a bucket of water out of the ocean and wondering if you're going to empty the ocean. There's no impact.
Stem cells are like little nano machines. It just takes a couple to self-replicate and rebuild your bone marrow. So they're rapidly generating way faster than something like the liver that can also regenerate.
Oh, totally. Right? And there's a stimulus. It depends what is needed. They can replicate very fast.
Christian, you and I are both interested in extreme longevity reports throughout history. And it has to be throughout history because if you're trying to find people who've lived longer than 120 years, it's historical. I'm aware of a case that's well documented in India of a guy who lived to 185. Have a book about it downstairs. And you have looked into a guy in China who's reported to live or to have lived for 250 years. And yeah, there's all kinds of detractors say that can't happen because it didn't. But let's assume that everyone on the planet isn't an idiot because they don't believe the same things you believe. So we're just being curious about this. What was the reported practice of this guy? Tell me about him.
So it's a fellow in China. I think his name was Li Qingyuan, at least English pronunciation of his name. Born in 1678, and I think he passed in 1933. Basically the challenge there, like you just said, it could not be true because nobody can live that long. And if it's true, then show his birth certificate. Well, go back your grandfather 10 generations ago and tell me if you can find their birth certificate. So looking back at the history, and again, like the one that you mentioned in India, tons of documentation. And when he's asked what is the secret of his longevity, there are three main things. Number one, he was using a lot of plants, and very interestingly, he was using plants like goji berry, foti, and then reishi mushroom. All three were shown to support stem cells. Goji berry, reishi support the migration of stem cells. Foti release stem cells. We did these studies years ago. We even filed a patent on it. So very interesting. He was stimulating his stem cells. Second, at 250 years, when in a meeting he's offered a chair, and he refuses the chair. He's sitting down on the floor with his back straight. So he walked 30 miles on that day to go to that meeting. He refused to get into a cart pulled by horses. So muscle activity, physical activity, every day of his life. And the third one, he says, have a light heart. Yeah. And that was his main comment, have a light heart. So don't worry about anything most of the way. It makes me think of Mark Twain when he said, I spend my entire life resolving problems that fortunately never happened. So all the stress of the stuff that we make up in our own minds that actually do not reflect reality at all, just let it go. So anyway, so that was is secrets to longevity.
I've always been intrigued by these reports of people living a long time. And you look in the Bible, you look in any ancient religious text, they talk about it all the time, hundreds of years. It could be that all of them are just crazy and lying, or it could be that we believe some things that aren't true. Some of these texts also reference ancient cities. And then, oh, look, someone reads the text and goes and digs in the sand. And what do you know? There's a city there. So I can't say with 100% certainty, and no one can, that all of these reports from around the world are real or false. But I think there's a pattern that's worth paying attention to. And funny enough, this guy had a very specific protocol that was stem cell focused. So I think they're a part of living a very long life and certainly living healthy until you are going to die.
And there's documentation of these, like you go back to the biblical times. I mean, there's no verification. There's absolutely nothing to verify. You believe it or you don't. So let's say, even if you put these aside and you go to places like people like the fellow that you talk in India or this Chinese man, there is a lot of reports at the time of his living. Like, I think like every 50 years, he got a certificate for his longevity. Well, at 250 years, it's a bunch of certificates that were confirmed. So there's a lot of traces of his existence during all that time. So even if we don't believe 256, let's say he lived a long time, at least 150. And in that way, to me, what is so powerful about these testimonials is that you can't achieve what you don't believe in. So if you don't believe that you can live 200 years, your mind is such that you cannot reach it. So the moment that you see these cases, it kind of breaks your ceiling in beliefs. And now the moment that you start to accept it and believe in it, it gives the collectivity the ability of basically reaching reaching greater longevity just by belief.
One of the things I do for that is when I celebrate my birthday, I just do it in percentages of my minimum. So I'm very serious about living to at least 180. And it's less about not dying. It's more about living all the way as long as I choose. And when I look at the practice of doing that, telling my body that it's at 29% duty cycle is a lot more effective than whatever dumb calendar age. So I think that's part of that, being light in the heart and just having a worldview that says you're going to live a lot longer.
I mean, that's one thing that all centenarians or centenarians have, is that they do not develop a disease until just a few months before passing. So somewhere, anything that can delay the onset of any disease or maintain the health that you have today is basically playing into this whole game of longevity. And that's where stem cells become, to me, like such a central part of this whole question.
Beautiful. One of the mysteries of the body is that we have these microcapillaries, and they're smaller in diameter than red blood cells. So somehow we have this little straw, and you're sucking a bowling ball through a straw, and it cannot happen because of pressure. You can't blow something through a straw that's bigger than it is. How does that work, and how does it affect stem cells?
Well, the red blood cells themselves are just about the size of a capillary. So the real question comes with stem cells. Stem cells can be up to 20 micron. Your capillaries will be about up to 12 microns. So, and when you think about the fact that stem cells are the repair system, if they don't reach capillaries, that's the place where stem cells can leave the blood and go into tissues. That's where the machinery for that migration exists. So if stem cells cannot get into capillaries, that area of the body deprived of proper microvasculature is deprived of repair. And I think that this is one of the main thing of any kind of chronic issues, is that it needs repair, but stem cells don't have access to it because the chronic nature of the problem has basically rendered that microcirculation ineffective. And that's where we're talking about adding up a number of how could I say, strategies here to improve microvasculature, nattokinase, to digest fibrin so that it brings more entrainment. If you go with a microscope and you look at blood circulation and how cells get into these capillaries, you see immediately that it's the entrainment and the force of the flow that really entrain these cells into small capillaries. Dilation with nitric oxide producers, rebuilding the glycocalyx that really supports the stem cells in their circulation. So these are different things to do to basically allow stem cells to get access to that, everywhere in the body.
There's also the role of sunlight and infrared light. We've finally figured out that there's exclusion zone water. And it's one of the things that propels cell biology. And this comes from body heat or sunlight holding water up against cell membranes or any kind of fat. If you were to blend some butter and MCT in your Danger coffee, it makes exclusion zone water, according to research from the University of Washington. When you take some of the ingredients that are in STEMREGEN that increase nitric oxide, so now you've got a bigger pipe, and we'll just say more lubrication because you got some sunlight or some exclusion zone water from blending fats into water. And then all of a sudden, that creates the transport system to get the stem cells through these tiny little pipes so they can get where they need to go. And that's why for a lot of people, like, well, I did one thing that needed to work. And you just got to think of it like baking bread, okay? When do you add the yeast to the flour? How long does it need to sit? What's the next step? Does it rise? When do you bake it? And there's people who will say, I just wanted to take a shortcut. So I just bought some yeast and I threw it in there and I baked it. And they got a cracker, not a loaf of bread, because they didn't have the recipe right. So I feel like when I'm using STEMREGEN, getting sunlight in the morning is a really good idea. You know, drinking some coffee with a little bit of butter or MCT blended in, it's going to help my body have more exclusions on water. Whole body vibration, all these things, they work together as part of the recipe of performing better and healing faster. Are there any other lifestyle things that you recommend to use with STEMREGEN? Like hot or cold or what?
But before I go there, I just want to emphasize that what you're bringing up there is a super, super important point that is kind of well talked about within the biohacking community, but not a whole lot outside, which is stacking. Do more than one thing, because the direct offshoot, the direct outcome of science is that you need to study one thing and remove all the other variables to prove that that thing is working. But in your life, you never do one thing outside of other things. And it leads the world to a large extent to do one thing, to help an issue. At least the medical system will look at it this way. But in reality, life is absolutely not like this. So stacking stem cells, but then microcirculations, surface tension of water, like these are all stuff that we need to add together. So surface tension, try to use restructured water. Huge difference in order to support circulation into, you try to push water into a micro vessel. And if that water has a high surface tension, it can literally bounce at one of these forks and not get into a capillary. You reduce surface tension of water by using something like restructured water, and you maximize circulation. Like the impact is amazing. So that's one thing that we can add. Cold plunge is great. Pulse electromagnetic frequencies. This is something that I started to really look into it actually not long ago.
It sounds like you've been to Upgrade Labs.
There you go. So you do that at Upgrade Labs. There you go.
We've been doing it for 10 years now for people, help to make PEMF part of biohacking because it's so powerful. So you started getting into it.
So you start to dig, because I asked this as somebody who was an expert in that field, and I said, is there a link between stem cells and PEMF? And you looked at me straight in the eyes and you says, duh. So I started to dig in the literature, and I will go as far as to say that actually with the bulk of literature on PEMF, it's probably actually the main mechanism of action. PEMF will support the migration of the circulation of stem cells in a tissue, their migration into a tissue, their proliferation into a tissue, and their differentiation. So far in the clinical trials, their differentiation into tendon, ligaments, bone, muscles. So anything that is joint, the benefits that you get to a large extent come from leveraging the effect of stem cells. So now you release stem cells, and then you use PEMF, and you really boost the effect of what you've done with STEMREGEN.
I think there's a case for doing STEMREGEN and then going into Upgrade Labs and doing PEMF. And certainly it's going to activate stem cells. It also creates something called BMP, or bone morphogenic protein. And it does this because of an effect called a piezoelectric effect. And what that means is when you create that strong magnetic field around the cells, they make a little bit of electricity. And that electricity likely attracts or interacts with stem cells, so they go there. I have stupidly high levels of bone density to the point that they had a hard time cutting through the bone during a bone surgery. And the doctor was just flabbergasted. He's like, I've never seen this before. What are you doing? Like, well, I have lots of stem cells, right? I have Upgrade Labs doing PEMF. I get lots of minerals, and there's STEMREGEN. And of course, I've done a lot of other super esoteric stem cell procedures.
In vibration, you use vibration.
I do a whole bit of
That's a big one.
vibration. Yeah, introduce that to the biohacking field as well at Upgrade Labs. And in fact, I used to make one back when I was at Bulletproof. So all of these things, they affect stem cells and they affect bones because stem cells right around inside the bones, at least some of them do.
And you mentioned something that I think is super important. It's PMF. It doesn't have an effect specifically on stem cells. So based on my training in neurophysiology, or let's say knowledge in neurophysiology, and it extends to any other cells in the body, there's a difference of electrical potential difference at a cell membrane. That electrical difference, potential difference, is what the cell will use to drive specific compounds in and out of the cells. Mm-hmm. So for sugar, for example, yes, insulin is needed, but you need this difference of potential to then drive. It's like a waterfall that the cell builds and then utilizes to bring in stuff. If you don't have the difference of potential, a cell is actually unable to function normally. And it is really, so every cell is a battery in a way. And PMF actually gives that to the body. So when a cell goes into that field, it gets recharged much more easily. So it brings every single cell of your body needs that electrical potential, that voltage difference potential to function normally. So it's stem cells, but it goes far beyond stem cells.
You need clean, high-quality protein in your diet. That's why I recommend Puree PW1 whey protein. It's made from pasture-raised cow's milk. It has no hormones, GMOs, and pesticides, and it comes in 2 flavors that taste really good: bourbon vanilla and dark chocolate. Puree's PW1 is third-party tested for over 200 contaminants you might find in other whey proteins, so you know exactly what's in it. Puree certifies each batch with the Clean Label Project, which means they check for heavy metals, bisphenols, and other residuals you don't want in your body. You can even scan the QR code on the package, and they'll show you the test results for your specific batch. That's true transparency. Right now, because you listen to the show, you get 20% off the already discounted subscriptions. That's a savings of nearly a third off the price. I want you to have high-quality, animal-based protein that's affordable, and this is how to do it. To get that special discount, just go to puree.com/Dave and use code DAVE. PUORI.com/Dave. If you want to stay powerful, no matter how old you are, you want to keep your muscles strong and working. And you might think that the answer is to hit the gym harder, maybe for 2 hours a day, like one mistaken longevity doctor says. But there's a hack so that you don't have to add even a single rep. It's called MitoPure by Timeline. As you get older, your muscles naturally do shrink. It's one of the big causes of aging and people falling and stuff like that. Unfortunately, it means you feel tired and worn out first. And studies show that this is because your mitochondria are weaker. And there's great research going back over 10 years to back up this one compound. So give MitoPure a try for 2 months. Let it sink in and you'll feel the difference, or maybe even see the difference in your skin. Go to timeline.com/Dave. You'll get a great discount. This is something I use every single day.
It's funny. At Upgrade Labs, we measure electro potential in cells when you come in. And one of the things that can increase that is the type of minerals that are in Danger Coffee. So you have those 2 things. You're on your STEMREGEN. You do whole body vibration. You just stack all this stuff together. You're like, what just happened? Something different than I expected. But I want to ask you about some of the things you're doing with STEMREGEN. And by the way, guys, you stick around at the end of the show. Christian's gifting you 20% off. There must be some difference between the way a professional athlete would use stem cells and someone who's reversing aging would use stem cells or STEMREGEN. What's the difference in the strategy for using stem cells?
When you do recovery, of course, it's acute. So you do a physical activity that has created micro traumas, micro lesions and tendon ligaments and so on. So right at that moment, that tissue is signaling. So you want to release stem cells right away. So if you do intense physical activity and you want to recover faster, 2 STEMREGEN capsules right after release, right after or sport, right after the physical activity, 2 before you go to bed, and you'll see the day after your recovery is very different, just because you've tapped into your own repair system. When you start to think about longevity, and that is the part that, to me, of all of what we're talking about, is really the most, I don't know what's the right term. I was going to say the most fascinating, but it's the most like...
It's most important.
From a society standpoint, To me, it's like the biggest discovery of our lifetime. And it's to understand that at the core, fundamentally, we develop age-related disease. We talked about earlier longevity. What is common to centenarians is that they don't develop problems until a few months before they pass. So how do we develop age-related problems? It's because of that natural decline in the number of stem cells. So what stem cell research has revealed is that we experience aging like at an old fence in your backyard. Like every year it's older. It's in decline every year. But that's not how health is happening or aging is happening. So what stem cell research has revealed is that our health is like a bank account. You put $10,000 in your bank account, and for a long time, you look at your bank account and it stays at 10,000. That's because you have as much expense as you have income. Mm-hmm. And that bank account is not static. It's very dynamic, but it doesn't move. But as you age, you have more and more expenses, more and more cellular loss, and less income because you have less and less stem cells. So suddenly your bank account starts to shrink. That's your health. The day that you run out of money, that's bankruptcy. That's the disease. So the point is that aging is the same. It's a balance between your income in stem cells, your expense in cells. As we age, wear and tear makes us lose more and more cells, and the decline in number of stem cells makes us less and less capable of offsetting that cellular loss. So if you lose too many cells in your pancreas, that's diabetes. You lose too many cells in your heart, it's heart disease. You lose too many cells in your brain making dopamine, that's Parkinson. Every single age-related disease that is going to shorten your lifetime develops because you don't have enough stem cells. So from a longevity standpoint, all you want to do is every day just release stem cells, more stem cells in your blood circulation to offset cellular loss. And 10 million stem cells a day with STEMREGEN is enough to allow your body. Think about it. In a month, it's 300 million stem cells. If a 100 million stem cell injection is like great for you, think about 300 million that you release in a month just by taking STEMREGEN every day. To me, it's like the primary longevity strategy.
Well, compared to the cost of getting and pain of getting your stem cells taken out, and there are benefits to doing that because you can introduce them into the right place and all that. Compared to that, or just take a couple STEMREGENs and get a high dose of stem cells regularly, I think there's room for both. And because it's so much more affordable to do STEMREGEN, I think it's just a normal, healthy part of a comprehensive longevity strategy. It's still not as cheap as vitamin C or minerals or something.
It doesn't do the same thing.
No, it doesn't. And just for people listening, you build your stack over time that do different things. And maybe you say, okay, I know if I'm going to work out heavy or if I've been injured, I want to do STEMREGEN. So maybe only take it sometimes because that's more economical. There's nothing wrong with doing any of those things. So it's okay to space things out when you need to. Do we have evidence that the mind actually controls your stem cells?
Super interesting question. No evidence that I know of. However, the machinery for this is all there. What I mean by this is that if you inject GCSF in a mouse, in an animal, which triggers the release of stem cells from the bone marrow, and you do this after having injected blockers of noradrenaline, you do not get stem cell release. So noradrenaline, which comes from neurons, from nerve terminals to your bone marrow, noradrenaline is essential for stem cell release. Now, every stem cell in your body has receptors for all the main neurotransmitters. Now, we know that the blood vasculature, your fine capillaries, have nerve terminals, tons of nerve terminals. That's what you lose when you have neuropathy. So basically, the whole machinery is there to say your brain can affect the release of stem cells, can affect their migration in the tissue where you want these stem cells to go. And that is why I'm thinking, I remember when I was a kid, teenagers maybe in Montreal, and I read that story of that fellow who dove into a pool, and he did not know that the pool did not have 6 feet of water, so he basically snapped his neck. So he was fully paralyzed, and within about 3 years, he completely regained all mobility. And what he said is that he spent 3 years in his bed visualizing light and reconnection of his spinal cord. And he regained mobility. And it always stayed with me because in medicine, there's no explanation for this. And I'm just thinking right now, well, maybe the mechanism of action behind this is that you release stem cells using your mind and you can drive them where they need to go. So the machinery is there. I'm not aware that it has been scientifically documented.
I look at and things like that. And there's so many cases of it. Joe Dispenza's doing a lot of work on showing that the mind does affect systems in the body. And he'll be speaking at the Biohacking Conference in May in Austin, and you'll be there as well speaking. And I think there's convincing evidence of it. I've felt it. One of the things that we do know is that a baby, when there's one cell that's been fertilized, every cell has every gene. Mm-hmm. So how does the cell know what to do? There's no instruction manual for what cell is going to become a liver versus a brain versus an eyeball and all of that. So something has to be controlling it. And it is almost certainly either an information field or a quantum field. So we have all these low-level effects, and we know that stem cells, in fact, a lot of biochemistry runs on quantum effects. Those microtubules, the little capillaries, the way they're sucking stem cells through them is actually because of a quantum effect around water. So given that we know the mind is a quantum system, and yes, I've talked about the studies that prove that. So if the body is a quantum system and the mind can affect the quantum stuff that underlies reality very provably, even though we can't see it, I think there's a mechanism there as well. But like we said, those are hard to prove. It wouldn't surprise me if someday there's going to be some guy who can tell stem cells to spell words on a slide dish with his mind. But until then, we're going to have to say, it looks like it could work that way.
There's no doubt in my mind that what you just talked about has an effect on stem cells. Let me first start by saying, from a purely physiological standpoint, like you said, every single cell has the full DNA. But so that means the heart cell that is different from a liver cell, that is different from a skin cell, they all have the same DNA. It's just different parts of the DNA that have been turned on. So when a stem cell gets into a tissue, let's say the liver, and it's in the community, if you want, of other liver cells, there are specific molecules that are unique to these different tissues. Albumin, for example, in the liver. So I think that to a large extent, it's these proteins that are specific for a tissue that will tag a receptor at the surface of the stem cells, send a signal to the nucleus, and now it will activate all the part of the nucleus that will make that cell now transform into a liver cell. So there's a good physiological process that has been documented into the transformation of the stem cell. What is, to me, more part of the quantum part that you just talked about is that it's one thing to have a stem cell transform into a liver cell or into a skin cell. It's a completely other thing to say these cells now will develop into the complete infrastructure and ultrastructure of that organ. It's not just becoming a hepatocyte or a pancreatic cell. It's to make these pancreatic cells develop fully into like full islets of Langerhans, all organized spatially into the different type of cells to make the whole part of that body function completely normally. It's a stem cell getting into the brain, becoming a neuron, supported by glial cells, supported by capillaries, the whole tissue. What makes stem cells develop all the ultrastructure of that tissue? There's no science for that. This is like mind-blowing. Like your skin, like your fingerprints. You burn your fingerprints. Your skin repairs with stem cells, and you still have all the fingerprints as you had them before. How do you do that?
Wait a minute. I'm going to put on my Peter Attia hat. There's no science for that, therefore it doesn't happen, Christian. What are you thinking about? It's unscientific.
I mean, what you're saying is funny because we need to understand it is the science tells you what you cannot quantify and document, therefore is not true and is not real. And to me, and I like that approach in as much as it allows us to probe reality in a strong way. Not to assume that what you can probe is reality and it's all it is. That is actually falling onto the dumb side of things. Because like, what is the greatest force in nature with all of us human? Is it not love? Show me the love meter that allows to quantifying it.
I think it's actually the stubbornness of a 2-year-old.
That's But how can you measure stubbornness of a 2-year-old? There's no machine, so therefore it does not exist. I think we have to kind of grow beyond, like, it's a nice approach. It's a little childish.
The role of science is to tell us a story that's useful for understanding and predicting reality. And we know because of science that all of the reality we perceive is not actually reality, which is very frustrating. and even time. I mean, Einstein and everyone else, that's kind of a myth. We just believe in it. So what science does is it tells us these great stories like, oh, because of this, I can predict this. And it happens almost all the time. And because of science, when it's working correctly, it means it works almost all the time. But there are times when something else happens. We go, wait, that's possible? And then we zoom in on the outliers, the ones that don't happen most of the time, to figure out the mechanisms and to give ourselves a better story. And people say, well, I believe in science or have science-backed advice, and people who don't agree with me are not scientific. They're just bullies or sad people, because the reality is the things that no one understands is where all the innovation happens. And it is science to look at those things. And it is science to look at our story and say, that sure is useful, but it isn't accurate. And this is why I've had Nassim Harim on the show, who beat the standard model by something like 6%. He's a ski instructor. So they're like, well, that's not possible. Well, actually it is. And this is why you look at what the difference between Newtonian physics, which is a great story, it's not science. It just isn't science because it doesn't describe reality. It's a part of science. It's a useful story. And now I'm going to piss off all the scientists out there. We used to have a story that it was fairies and leprechauns that did it. And that was the most useful story we could make at the time. And our stories get tighter and tighter. And I believe every single thing we believe as scientists, and I come from a scientific family, I am a scientist, every single thing we believe is a story about reality that we will change as we learn more, which means it's not fully correct. It's just directionally accurate, unless it's just not. And that sure is confusing, and it requires you to take a deep breath. And if your entire life's work, like let's say you're someone who believes you can't extend life and that the only thing you can do is over-exercise every day. Okay, if you've been saying this and getting paid $250,000 a year to say this for a while, you will never change your mind, because that's going to be a lot of crow to eat. And this is why we see big pharmaceutical companies who will tell you, do statins, do statins. Yes, they make money, but if they admit they were wrong, they have liability for all the bullshit they've been peddling. So your job, one of the reasons I like you is like, how does it work? What are the things we don't know? Is there a way to push on this lever? Is there another way to do that? And that natural curiosity comes from somewhere. Does curiosity come from stem cells?
I don't know. We'll have to do a study on that, a scientific study on that.
But I don't think so, but it's a good thing.
I agree with what you're saying. You know, I think the flaw is to assume or believe that science shows you reality, when science just allows you to poke and investigate it. Science, the reality is beyond science. Science is really what can be quantified. There are many things in reality that cannot be quantified. And we can touch them, we can experience them through science. But to say that everything is limited to what we can quantify, to me, there are some like blatant aspects of science. For example, we don't have to dive into this, but reincarnation in past lives. Scientifically, if your proof is that somebody will come back and will show you that they were the other person, then that will be the proof. It may never happen, and yet there's tons of evidence, tons and tons and tons of evidence that it's reality that can probably never be grasped by science if you want to approach it in a very, very stringent and rigid manner. So science, rigid science, that only consider what can be quantified, leaves out a whole portion of reality.
When science can define what consciousness is, then we're getting somewhere. And until then, I think there's a lot of comforting ourselves with science. And science is such a powerful force for figuring out how systems in the body work. It's fantastic. It doesn't mean it's real. It doesn't mean it's true. It means it's useful and it's directionally accurate. And there's always another layer, and finding those new layers is what I think is going to unlock our longevity. And a big part of this is, the quantum nature of microtubules, how stem cells know where to go in the body, how do we direct them with our consciousness. Mm-hmm. All of these are TBD in science, but to say none of those are real because they can't be real is the height of hubris.
Quantum physics will change is changing all of that.
It is.
As you just say, will change. Already, if you dive in what we know of quantum physics, it changes all of that already.
Yeah, it's pretty ungrounding. One of the things that's been fascinating me since my big longevity book a few years ago is looking at biological clocks. And David Sinclair, who's been on the show a couple of times, just saw him at the American Academy of Anti-Aging Medicine where we both spoke. He was the first guy to say we can reverse cellular aging. And I'm interested in doing that, and I've done a lot of protocols for that. There's also some work I've done at RMI. You guys can go to daveasprey.com/RMI for that episode. And there, we were reversing the central aging clock in the brain. It's a very expensive procedure. But there's also a liver clock, and there's a skin clock. I want to know, do stem cells have their own biological clock that we can reverse, or do they step into a part of the body and then join that clock system in that part of the body?
I think of what we know today, I would say that that's probably what it is. So stem cells will become cells of another tissue, and then will adopt in the clock of that organ. This being said, we already know, we talked about before, fasting rejuvenates your stem cells. So if you measure stem cell function in terms of their ability to proliferate, migrate, transform into different types of other cells, if you quantify that, and you determine that as being their biological age, like they behave like your stem cells 10 years ago, fasting right now achieves that.
So stem cells have a biological clock like any other cell, but there isn't a central stem cell clock that we're aware of.
That I'm aware of at this point. I would not be surprised that becomes identified.
It's probably in the brain. Wouldn't surprise me.
I mean, if you talk about a clock, technically you talk about the time when a cell lose its ability to be immortal. You know, if I push this to the extreme, stem cells are immortal in your body. So they will multiply during the entire life of an individual until such time as they become too clogged with their own cellular division and they have too many debris and they're not really effective. So if fasting allows to reverse that, that's probably your clock in a stem cell.
Most of the regenerative techniques that are in Superhuman, my longevity book, are around extracellular debris, intracellular debris, stiffening of cells, mitochondrial function, and telomeres.
Membrane.
Are all of those relevant to stem cells?
Absolutely.
So if you're going to reverse your age systemically, including skin cells and all the other cells in the body, then you might as well, with those same techniques, do the same things for your marrow and for your stem cells. And I believe that's a systemic effect because of all the stuff I've seen about it, which is really powerful because the practices of longevity also give you younger stem cells. And that's really powerful as long as you can mobilize and release them.
Yeah, I think one of those that are not talked enough about, although I think I've heard you talk about it, which is the health of the membrane. Lipids that are in the membrane. We talk about electricity before, the building of this voltage difference between the inside and the outside of a cell. Well, the ability of a cell to maintain that voltage difference depends on the health of the membrane, which depends on the actual constitution of that lipid membrane. So all the lipids that we take by mouth has a huge impact on what is going to be the cell membrane of the membrane of these cells, which drives basically the physiology of every single cell in the body. So all this emergence of cell membrane replacement, that kind of stuff, I think this will play a huge role in longevity science and in the near future.
It is going to play a huge role in longevity science. The other thing I'm really interested in, how soon are we going to be able to hack our stem cells with CRISPR or gene editing or some other technology to tell them to do something better or younger or to give us superpowers?
I mean, right now, and this may be a limited statement, right now I would say I would probably trust nature more than try to start to hack the genes.
Nature is mean. She wants you to die and get out of the way.
And what I mean by this is that there's a reason why, for example, your abilities of stem cells to multiply kind of declines with age, because if they're not controlled, that's cancer.
Wait, but we're not trusting nature when we take STEMREGEN. We're telling nature, you're not giving me enough stem cells, bitch. Like seriously, you're making me age because you're not making my marrow do what I want. So I'm going to step in. I'm going to send the signal in.
But I'm not changing the code of these cells. I'm leveraging natural phenomenon in the body. And as long as we do this, I think that it's, it's safe.
It's definitely lower risk.
Definitely.
But maybe it's lower returns.
Could be.
If you could edit your own stem cells, to do anything you wanted and it was safe, what would you do?
I mean, I think it becomes a personal question. What
It
I
is a
mean
personal
by this
question.
is that
Yeah.
you need to go and really find what is weak in your genetics and then take stem cells, do that change in the genome of that stem cells, multiply that stem cells into a population, and then reseed your bone marrow with these stem cells. That is probably going to be a future application of stem cells.
I'm planning on doing it relatively soon.
Relatively soon, because all the stem cells now that you have in your bone marrow have corrected that gene, but you've not affected the immortality of that gene, of that cell. That's where I don't know if it's right or wrong, but that's where I'm thinking there's a natural process that limits the power of these stem cells as we grow, and it could be a protection against cancer or different aberrations. So that's the part of nature that I'm just cautious of trying to stimulate too much, which is different than what you're talking about. When you use CRISPR, we don't change the immortalities of these cells. We just change the nature of these cells by basically correcting weakness that you could have in your genome. It's definitely a place where stem cell research is going.
That is super cool. I'm interested in editing my mitochondria. I'm interested in editing my stem cells to be pluripotent so that they can do whatever I want them to do. And I think we're right on the cusp of this.
I mean, it's already done. Yeah. You go to, like you mentioned, RMI before, and they're doing that kind of work. Taking of stem cells, inducing clothogenes, which has been associated with longevity, and starting to do these kinds of manipulation done in humans, as you know.
I'm going down there next month.
There you go. I mean, I'm extremely curious about it. I'm not sure if I would do that quite today, but
yeah, so someone has to. Now, let me ask you this. Do you think it's possible to enhance and extend what you're doing with STEMREGEN so that it causes stem cells to not just get released and move around, but to do something new they haven't done before?
Let me answer maybe indirectly, but there's a video that I show when I give presentations just to really shock the minds about the raw power of stem cells. So it's the heart of a mouse that has been removed from the animal. Then in the lab, they circulate proteolytic enzymes on the cardiac muscle. So after about 12 hours, they're left with the entire heart is completely digested. All that you're left with is the soft skeleton of the heart, like the connective tissue of the heart. And on that connective tissue that still retains the trace that it was a heart, they lay out the stem cells extracted from that same animal before. Within a week, you get a beating heart in the test tube.
Crazy.
So your stem cells can entirely rebuild the heart. That's mind-boggling. So to me, the question is not so much, can I make my stem cells more effective? It's more, how can I unleash the raw regenerative power that they have? What is it in the body that limits the full expression of that regenerative potential? And that's why we came out with products like Mobilize that opens the microvasculature. One of the reasons is my stem cells, do they reach that tissue? Another one is systemic inflammation. Systemic inflammation will activate stem cells in their ability to migrate outside of the area where you have the injury. So you mess up these stem cells in their ability to really find where to go and do their job where they need to do it. So these are two things that have been cleared out, from the path in terms of their ability. And I'm sure there are other things, but the idea is like, how can we maximize their potential? Because they have it. I don't think we need to trick them or really magnify their ability more than what they can do in their raw potential shown in that study.
It's true. One of the things in biohacking that I've said for a long time is I believe we should maximize the potential of our own hardware before we replace it. This is why I'm not a fan of replacing my eyeballs with cameras or something. Some of the transhumanism stuff, it seems like we're not paying attention to what biology can do. And I'd rather just use my existing hardware. Or I'd rather, say, get a gene from the axolotl, which is the logo for Upgrade Labs. This is a salamander that can regenerate any part of its body over and over. I'd rather do that. And sure, if I need robotic legs at some point in my life, okay. But that would be my last thing after I really went deep on what my innate biology can do. Can I just grow new legs using my stem cells? Or do I have to change the stem cells?
It has been done.
Weird. It's coming, and it's coming so fast. It's super cool. Christian, you're doing some really cutting edge work, and I love the way you think about we'll say the spirituality of stem cells and extreme longevity, and the very practical approach of saying, well, let's look at all the plants that can release stem cells, and the idea that for a little bit more than $100, you can have 300 million stem cells that you otherwise wouldn't have, which unlocks stem cells for a whole swath of people who aren't going to go spend $10,000 and leave the U.S. And the people who are doing random umbilical cells within the U.S., I think there's a lot of risk there that I've seen from multiple people. So I don't recommend doing that. So your options are stay in the U.S., take STEMREGEN. By the way, guys, stemregen.co/Dave for the 20% off. But you can do that. You can go south of the border and you can do some really creative stuff, but it starts having a lot of zeros on the price tag. So if everyone's going to get stem cells, especially after a heart attack, after an injury, after even just a rough weekend, STEMREGEN is really the only cost-effective way that I've found in order to do that. So thanks for making it, and thanks for coming back on the show.
Thank you. And by the way, you're mentioning, releasing your own stem cells versus stem cell injection. Without getting in there, just some results now on a preliminary study not preliminary. Yeah. It's an ongoing study, but we have a preliminary report that we just filed about 4 weeks ago in the peer-reviewed scientific literature. So it's accepted not for publication, but for review. So we'll be able to say more about this later. But essentially on 10 people with chronic stable congestive heart failure. Ooh. So people who have been treated by medicine with everything that medicine can do, and for at least 2 years were in that condition where, let's say, they walk one flight of stairs, then they need a chair to sit and let's say recover their breath for like 5-10 minutes. So we take these people, we put them on STEMREGEN, and 6 months later, 10 out of 10 have normal heart function. So it's just to show here, the point is not to say the product helps you recover from heart disease. The point is just to show that all the problems that people have in their 50s, 60s, 70s, they did not have them when they were 20 and 30.
It's true.
Because they had plenty of stem cells to offset any kind of cellular loss. And when you don't have these stem cells, the problem slowly develops. So all we do is that we give back to the body its own native ability to repair, as you did, 10, 20 years ago, when none of these problems were there. That's the leverage that we're really creating.
It's so impressive. And I do want to say, as we wind up the show, you were kind enough to send my parents a bunch of STEMREGEN, and they've been on it for I think probably about 6 months now. And they're both substantially better than they were before. And as parents will just say, well, we're not really sure what it was, but could you send some more? So I did notice a meaningful improvement. So thank you for your generosity there. And my parents have a lot going on. So that's one of those things that says there's a systemic effect. It's not just one thing. It's everything that requires repair of inflammation and old damage and aging. Thanks again, guys. STEMREGEN.co/Dave.
See you next time on the Human Upgrade Podcast.